Hello, this is Murray Middleman, and I'm back to discuss the results of your critique of a cross-sectional study. As you recall, the paper was about lead and cadmium levels and balance and vestibular dysfunction among adult participants in the National Health and Nutrition Examination Survey from 1999 to 2004. What I'd like to do now is discuss your responses to each of the questions that were posed. I'd like to thank you all for your participation and posting answers on the website. I have found this quite useful to review, and I hope you have all found it useful to see what your colleagues were thinking about the individual questions. So let's turn our attention to question 1. How was the population selected? Well, in this study, the investigators used data from the National Health and Nutrition Survey, which, as we know, is a population-wide survey that's meant to be representative of the U.S. adult population. And in this particular component, they took a sample of the participants from the 99-2000 survey. They took 50% of the participants who were aged between 40 and 69 years to conduct the assessment of hearing and as well as vestibular function. In addition, from the survey years 2001 to 2002 and 2003-2004, the NHANES had recruited all of the subjects who were at least age 40 years. And this resulted in a total of 5,851 participants, of whom 5,574 also had blood and cadmium measures available, in addition to having data on all of the covariates that were considered. This was the starting point for the study population. In addition, there were some exclusion criteria. When they were conducting the NHANES survey, participants were excluded from the balance test if at the time of the exam they were felt unable to stand on their own, had current symptoms of dizziness or lightheadedness, weighed more than 275 pounds, had a waist circumference that didn't accommodate the standard-sized safety gait belt, or needed a leg brace to stand unassisted, or had a foot or leg amputation. In addition, subjects who were blind or visually impaired, who would not be able to complete the test, were excluded. The second question asked, what was the time frame in assessing the relationship between exposures and outcomes? And here I've posted the result of one of the participants in the course who summarized the response to this question by saying the exposures and outcomes were tested concurrently. This was not a longitudinal survey. Individual participants were not followed over time. And so, as the title of the critique implies, this was a cross-sectional study. And this does limit some of the inferences that we can make as a result of the design, as we'll see in the response to upcoming questions. Question 3 posed a question about assessing the exposure. So what was the exposure of interest and how were they measured? The primary exposure of interest were levels of blood lead and cadmium. Lead and cadmium were measured from blood samples that were taken from subjects who were tested in a single lab. The actual values were retained for all samples and that were above the limit of detection. And if they were below the limit of detection, a value of 0.707 was substituted as below the limit of detection. Question 4 asked the question about what were the outcomes of interest and how were they measured? And the outcomes of interest in this study were really looking at outcomes of balance and vestibular function, and they were described in the methods section of the paper quite clearly on page 413 to 414. And essentially they came down to 4 modalities of a balance test known as the Romberg test. And this was done under increasingly difficult test conditions. Each test resulted in either a pass or a fail, and the 4 conditions were progressive, meaning that the test was stopped as soon as a participant was not able to complete the test at a given level of difficulty. In addition, for subjects who made it all the way to the 4th or most difficult condition, there was the time it took them until they failed the test or until the end of the monitoring period of 30 seconds was also recorded. And this allowed for an additional analysis to be undertaken that asked the question about the time until someone lost their balance. Question 5 asked for a summary of the main result of the study. And here, the primary result of the study was that looking at the adjusted odds ratio for balance dysfunction in association with higher levels of both lead and cadmium, the authors chose to focus on a contrast between the highest quintile, or the highest 20% of observations in the population, compared with the lowest 20% of observations. For lead, what they found was that the subjects who were in the highest quintile of blood lead level had a 42% higher odds of having documented vestibular dysfunction or balance impairment, and the corresponding 95% confidence interval was from a 7% higher prevalence up to an 89% higher prevalence odds. The corresponding odds ratio for cadmium, contrasting the lowest quintile to the highest quintile, was a 27% higher odds of having the outcome. And the 95% confidence interval ranged from 1% higher prevalence odds up to a 60% higher prevalence odds. In addition, the authors looked at the hazard ratio for time to failure for the physiologic most challenging tests. So remember, for the fourth level of difficulty, the investigators measured the time it took until an individual lost balance. And what they saw was that again, comparing those in the highest to lowest quintile of blood lead was associated with a 24% higher rate of falling compared to individuals in the lowest quintile. They did not see a consistent association with cadmium levels. Another important point to note is that the primary results of the study were summarized in tables 2 and 3, and these odds ratios presented in these tables were adjusted for confounding as well as for the sampling weights to account for the sampling scheme that was part of the NHANES study design. In addition, in tables 2 and 3, the authors presented results not merely for the first quintile compared to the fifth quintile, but also for the intermediate categories. And there was no clear dose-response relationship. In other words, they did not see the odds consistently increasing as individuals went from one level to the next level across the range. The sixth question asked whether the authors considered the possibility that the observed results may have been influenced by confounding, and if so, what were the potential confounders that were considered. As many of you noted in your comments on the website, the authors did consider potential confounders in their analysis. Now, recall that confounders are going to be the common causes of both exposure and outcome. On page 415, in addition, in the footnotes to Table 2 and 3, the authors state that they adjusted for the following potential confounders: age, sex, race and ethnicity, education, pack years of smoking, alcohol consumption measured in ounces per day, history of stroke and diabetes, and intakes of calcium and iron. In the discussion section, the authors acknowledge that possible bias due to uncontrolled confounding by unmeasured factors, such as family history and urbanization, could not be ruled out. So clearly, despite their best efforts to control for confounders of things that were measured and things that they thought would be related to exposure and outcome, was likely somewhat limited, and there may well be other confounders. In addition, there's also the chance that some of the confounders that were measured were not perfectly measured, and there may be some what we call residual confounding. For example, exposures like alcohol use and smoking are difficult to summarize as a single measure. So merely looking at pack years of smoking doesn't really capture all of the information there is to know about smoking behavior that may have influenced both the exposure to cadmium and lead levels, in addition to the risk of the outcome. Question 7 asked, what analytic methods did the authors use to take into account potential confounding? In the analysis, the authors used something called binary logistic regression that they describe as using a procedure in a statistical package called SAS called survey logistic. And this logistic regression was used to compare the prevalence of balance dysfunction for each quintile of lead or cadmium exposure relative to the lowest quintile of exposure. The statistical models were adjusted for the potential confounders, including age, sex, race, ethnicity, education, pack years of smoking, alcohol consumption in ounces per day, and history of stroke and diabetes, as well as intake of calcium and iron. It's important to note that the authors used appropriate methods that incorporated information about the complex survey design and the sampling of the population so that the results would reflect the association in the overall U.S. population based on the sampling scheme used as NHANES, and that's why they used the survey logistic procedure rather than the regular logistic procedure inside this particular statistics package. In addition, the authors stated that they estimated association between failure time for balance test and blood and cadmium levels using Cox proportional hazards model, with outcomes censored at 30 seconds for participants who completed the test without losing their balance. Now, what this is saying is that when they conducted the analysis among individuals who made it to the fourth or most difficult level of the balance test, they timed the occurrence of loss of balance up until 30 seconds, and then they stopped the test. They then used this model called the Cox proportional hazards model as a way to evaluate the relationship between the quintile of lead or cadmium level and the rate of falling during that 30-second interval. They conducted the analysis using this Cox proportional hazards model rather than merely computing the rate of falling because they wanted to incorporate adjustment for the potential confounders, as noted in the logistic regression as well. Question 8 asked, did the authors assess the possibility that the observed associations were due to chance? Well, in the analysis of the data in this study, the authors did evaluate potential for chance, and they constructed statistical models and reported the results of these statistical analyses. The primary measure of uncertainty that they expressed was the 95% confidence interval. As you've learned in the biostatistics lectures of this course, we know that the 95% confidence interval has an interpretation that if a study were repeated over and over again, 95 times out of 100, the true value of the parameter of interest would be contained in the 95% confidence interval constructed, again assuming that there's no bias or confounding present in the analysis. So the 95% confidence interval, in a sense, gives us a range of values that are compatible with our data with 95% confidence. Of course, any given interval may or may not contain the true value of the parameter of interest, and we have no way of knowing in any given study whether the 95% interval that we created actually does contain the true parameter or not. Question 9 asked the question, did the authors evaluate whether the association between heavy metals and the outcome varied across subgroups of participants? In other words, was there evidence of effect modification? In the paper as presented, the authors did not show any results separately for subgroups of participants, so they did not tell us about any evaluation for effect modification in this publication. Note that examining the association of interest at different levels of exposure, for example, in tables 2 and 3, where the authors looked at the association between being in particular quintiles of exposure to lead or cadmium relative to being in the lowest 20% of participants, is really just an elaboration of the main exposure-response relationship of interest and is not an evaluation of effect modification. Some people might describe that analysis as looking at different levels of exposure in a dose-response analysis framework. So checking to see whether more intense exposure or higher levels of exposure were associated with a higher odds of having the outcome. If the authors had separated the population into subgroups, for example, into men and women, and then reported the association between lead and cadmium on vestibular dysfunction separately for men and women, then we would have the opportunity to evaluate for potential effect modification by sex. Question 10 asked, on a scale of 1 to 10, What is your degree of agreement with the assertion exposure to lead and/or cadmium causes an increased risk of developing vestibular dysfunction? Base your answer on sound epidemiologic principles. Well, the study had many strengths and many weaknesses, just as many publications do. Some of the strengths to consider here was the representative sample and the relatively large sample size that was assessed. Careful measurements were made of both the exposures and the outcomes. There were many confounders that were considered that were measured well. And there was a careful statistical analysis that accounted for the study design, particularly the complex survey sampling, as well as modeling potential confounders. On the other hand, the study also had many weaknesses. The first one that we must consider is that this was a cross-sectional evaluation, and as a result, we can't determine with certainty whether the exposure or the outcome occurred first. However, when we consider the exposure to blood lead level or blood cadmium level and the outcome of vestibular dysfunction, it's hard to imagine a story in which the vestibular dysfunction led one to have higher exposure to those heavy metals. On the other hand, the cross-sectional survey is still problematic because we don't know whether the lead levels affect the persistence of vestibular functions rather than the incidence. And as we know, prevalence, as measured in a cross-sectional study, is a function not just of the incidence of disease, but also the average duration of disease. And so the cross-sectional nature of this really limits our ability to make inferences about the cause-effect relationships that may or may not underlie the association. The second important point to consider is despite the author's best effort at controlling confounding by measured covariates, it's likely that there were unmeasured confounders. In addition, there's likely that there was residual confounding by covariates that were measured and adjusted for, but perhaps not in a complete manner. For example, pack years of smoking does not capture everything that we would like to know about an individual's smoking behavior that may be related to their exposure to heavy metals, as well as their risk of having vestibular and balance problems. Another issue in terms of study limitations is that the statistical model that was used to assess the relationship between exposure and outcome appeared to be reasonable. However, it's also possible that the model was not perfectly specified. One of the limitations of using quintiles is essentially there's an assumption that as you go from the lowest to the highest level within each category, the risk, or in this case, the prevalence of the outcome is constant. And then it jumps when you move into the next category and the next category and so on. This is an unrealistic assumption about the relationship between intensity of exposure and the prevalence of outcome. In addition, the model that was used assumed that each of the exposures and confounders that were included have an intrinsic multiplicative relationship with the prevalence of vestibular dysfunction, and this may or may not be true. Another limitation is that there may have been some measurement error or misclassification of the exposure of interest, the outcome of interest, or even the covariates that were considered in their statistical model. And all of these could lead to some degree of bias in terms of the relationship between the prevalence of exposure and outcome. So in summary, this paper had many strengths and many limitations, and another issue to consider is this is one of the early papers evaluating this relationship. Clearly, there's a need for further attempts to study this to either refute the observation or perhaps find data that result in increasing consistency of the finding. One thing to point out here is that one of the reasons that this study is conducted as an observational study is that it wouldn't be ethical to do a randomized trial randomizing people to have a higher intake of lead and or cadmium, which we know has many adverse health effects. And so as a result, we could never address this problem ethically through a randomized trial in humans. Once again, I want to thank you so much for your participation in this study critique, and I hope you found it a useful exercise, and best of luck with the remainder of the course.